Hi all, welcome to new video of AK Math Academy. Today we are going to see some questions from exercise 5.1 of class 12 continuity and differentiability. So let's begin. So question number 3. In question number 3 they have given some 4 functions and they are asking to find whether the functions are continuous or not. So for that we have learned one conditions, right? Just one condition we have learned. What is that? Limit x tends to c minus f of x equal to limit x tends to c plus f of x is equal to f of c, where c is any point which is in the domain. Okay, and now so that is LHL equal to RHL, which is equal to function of c. Okay, now how do we do this question? It's very easy. So the point is not given, but let's assume that the point is c. Okay, so how do we write limit x tends to c f of x? We'll just write like this only, right? X tends to c and f of x is this function x minus 5, and we'll replace x here with c. So that's how we use the limit operator. So we'll get c minus 5. Here we are not taking left hand limit and right hand limit because this function is a polynomial function, so it is continuous and constant. Say for example, if we are given modulus functions like mod x minus 5, here we will use a different set of methods. Here we will use left hand limit and right hand limit because it's a modulus operator, right? So right now we are not dealing with that. We'll be having one modulus operator question in this question itself, but in different subpart. So we'll be looking at that. Okay. Now f of c. What is f of c? So if f of c and this is equal, we can say that our function is continuous at all points in the domain. So f of c means we are replacing x with c, right? So x we are replacing with c. So we'll get c minus 5. So what can we imply? Like this implies limit x tends to c f of x equal to f of c, which satisfy the condition for continuity. Hence f of x function is continuous at all points in their domain. This is how we solve first question. It's very easy, right? So we'll be solving the second subpart in the next video. So question B. Question B, it's given that f of x is a function where the function is 1 by x minus 5, and we should find whether the function is continuous at all points except x is not equal to 5. Okay, so at points other than 5 we should find whether the function is continuous or not. So let's see. Okay, how do we do this? Limit x tends to 5 f of x. What is it? 1 by, so if you substitute x, like in place of x, if we substitute 5, what you will get? 1 by 0, right? Or else 1 by 5 minus 5. So let's see, 1 by 5 minus 5, which is equal to 1 by 0, and this is not defined. So in this condition we can say that f of x is a function continuous at all points except x equal to 5. So we can say that f of x is continuous at every points. At every point is continuous, but at one point is discontinuous. Which is that point? X equal to 5. That's what we have to prove, or we have to show. Thus we can say that f of x is continuous at all points other than 5. Okay.